We've all been there, sitting in an airplane, looking out that tiny window, maybe feeling the rumble of the engines. But have you ever stopped to think about what's actually holding that entire metal tube together? Today, we're going to peel back the skin and look at the incredible, unseen skeleton of an aircraft.
I mean, really think about that for a second. A fully loaded jumbo jet can weigh over 400 tons. It's screaming through the sky, dealing with massive pressure changes, insane turbulence, and air that's 50 degrees below zero. So what kind of structure can possibly withstand all that? That's the fundamental question, and the answer is just brilliant engineering. All right, so to really get how these amazing machines work, we've got to start with the basics. The 5 major building blocks that pretty much every single aircraft is made of.
Okay, so first up, you've got the fuselage. That's the main body, where we sit and where the cargo goes. Bolted onto that are the wings, which generate all the lift. Then, way at the back, you have the empennage. That's the fancy word for the tail assembly, which keeps the plane stable and flying straight. And of course, you can't go anywhere without the engine mounts to hold those powerful jets, and the landing gear to get you back on the ground in one piece. But here's the thing, the structure's job is so much more than just being a big connector. It has to support all the incredible forces of flight, maintain that perfect aerodynamic shape, protect everyone and everything inside from the harsh environment outside, and absorb the massive impact of landing. It's a true multitasking masterpiece. So let's dive deeper, starting with the heart of the whole thing, the fuselage. This is really the backbone of the aircraft, the central structure that everything else is built around.
In the early days, there were basically 2 schools of thought on how to build one. You had the truss style, which is kind of like a bridge, a strong internal skeleton of beams with a simple skin stretched over it that doesn't really carry any weight. But then came the monocoque design. Think of an egg. The strength isn't in a frame. The strength is the shell. The outer skin carries all the load. It's incredibly strong for its weight, but it has one big weakness. That weakness, one small crack, could be disastrous, just like on an eggshell. And repairs were a nightmare. So that led to the modern standard, the absolute genius of the semi-monocoque design. This is the best of both worlds. It uses that strong, load-bearing skin, but it's reinforced with an internal skeleton of rings and long beams called stringers. The skin and the frame share the load, giving you that lightweight strength plus the robustness to stop damage from spreading. This is the key to modern aviation safety. And believe me, that resilience has been tested in some of the most terrifying ways you can imagine. Let me tell you about a flight that changed everything. Aloha Airlines Flight 243. It's April 28th, 1988, just a routine hop from Hilo to Honolulu. But it turned into an absolute nightmare. They were cruising at 24,000 feet. Suddenly, there was a massive explosion. An 18-foot section of the fuselage roof just ripped off. Gone. The passengers were suddenly in an open-air convertible, exposed to the sky, flying at hundreds of miles per hour. The cause? Tiny and visible cracks from metal fatigue and corrosion had finally given way. It's an absolutely catastrophic failure. But the semi-monocoque design held. The rest of the plane stayed together just long enough for the incredible crew to perform a miracle and land that plane, saving 94 people. That incident was a horrifying but necessary wake-up call for the entire industry. It led to a complete revolution in how we inspect and maintain aging aircraft, and it's a huge reason why flying is so safe for all of us today. Okay, so moving from the body, let's look at the parts that actually make the plane fly. The wings and the tail aren't just solid pieces of metal. They are incredibly complex, hollow structures, engineered down to the millimeter. Just like the fuselage, a wing has its own skeleton inside. You have these huge beams running lengthwise called spars. They are the main muscle, carrying most of the load. Then you have the ribs, which run from front to back, and their job is to give the wing that very specific curved airfoil shape. And finally, reinforcing everything are smaller stringers. This whole grid works together to manage the incredible forces that are literally holding the plane up in the sky. And here is one of the most brilliant bits of aircraft design. Where do you put all that fuel? Well, you put it in the wings. The hollow structure is sealed up to become a giant fuel tank, often called a wet wing. It's perfect. It uses empty space efficiently, and it distributes all that weight evenly across the plane's structure. But most importantly, it keeps the vast majority of the fuel far away from the passengers and any potential sources of ignition in the cabin, which is a massive safety feature. And then at the very back, we've got the empennage, the tail. The easiest way to think about it is like the feathers on an arrow. Its whole job is stability and control. The big fixed parts keep the plane from wobbling around, and the smaller moving parts, the rudder and elevators, are what the pilot uses to steer the aircraft left, right, up, and down. And finally, we gotta talk about the unsung hero of every single flight, the landing gear. This is the hardware that has to manage that absolutely brutal transition from gracefully flying through the air to safely stopping on solid ground. I mean, just think about what the landing gear has to do. In flight, it tucks itself away perfectly to keep the plane aerodynamic. Before landing, it has to come down and lock into place, without fail, every time. On touchdown, it has to absorb the impact of hundreds of tons of metal hitting the runway. And then it's not done. It has to steer the plane and provide the braking to get it safely to the gate. It's an incredible piece of machinery. You'll really only see two main styles. The classic tail dragger, with the little wheel at the back, is still around on some older or specialized planes. But pretty much every modern airliner you'll fly on uses the tricycle setup, with a wheel at the nose. The reason is simple. It's way more stable and gives the pilots a much better view, making it a whole lot easier and safer to handle on the ground. So, from that tough, resilient fuselage to the genius fuel-filled wings and that rugged landing gear, an airplane is just a symphony of structural engineering. So the next time you're on a flight, buckled in, and you hear that familiar thump of the landing gear coming down, maybe you'll think about that incredible invisible skeleton that's been working perfectly the whole time, just to keep you safe.